And of the ones that we've discussed today, we're going to discuss effect size last, but that does not mean it is the least of them. So there are certain things you're going to need to know how to do in order to calculate an effect size that were discussed in previous slides, particularly in the slides about statistical significance. So let's go through here and keep going. So assuming we have a simulated data set, this looks a lot like some of the graphing methods that we talked about in some of the earlier slides. And this is a single subject design where you have the baseline and the intervention. So we want to take this, which is a graphical representation of improvement, and examine it as in a different way, in a numeric representation. And so what you have to have an effect size, it's pretty straightforward. You have to have the mean and standard deviation of your pre-data and your post or treatment data. So one of the issues I have here with the way that this was designed and discussed is that it's including all of the data. For treatment, I would tend to just include the last 3 data points because we're looking at improvement, and this is sort of gradual. Anyway. So you have the means and standard deviations of the baseline, and in this case the entire means and standard deviations for this entire treatment group, or you can just calculate the means and standard deviations for these last few data points, right? So what you would want to do is do this all in Excel, as discussed in the previous slides as to how to calculate means and standard deviations in Excel. You will need to have at least 3 baseline data points and at least 3 post or last 3 data points for treatment to be used, because otherwise you cannot calculate the standard deviation, and without a standard deviation you cannot calculate effect size. Okay, and so it's pretty straightforward. Here's all of the stuff that you do, and here's the formula, but you don't have to do all that. You can just go to this website here and put in the effect size. So your first thing that you need to do on your own, I'd like for you to calculate standard deviation and mean. You can either do it in Excel like I taught earlier, or you can just go to this website and you can enter the data and it will give the means and standard deviations. So I did this for you on the next slide. It shows the means and standard deviations are 12 and 1, as well as 16 and 2 for pre and post treatment. You need an effect size. This tells you here what they mean, 0.2, 0.5, and 0.8. And by the way, whether or not it's positive or negative, that just depends on whether or not you compared the pre to the post or the post to the pre. So I don't tend to worry that much about if it's a positive or negative effect size. It's really about the size of it. All right, so you just would go into here and put in mean 1 is 12, standard deviation 1 is 1. Mean 2 is 16, and standard deviation 2 is 2. And then you hit calculate, and it's going to give you the information you need. Okay, so you're going to want to probably try and practice doing that. All right, so you're back from practicing doing that, and here's the results. So it's going to provide you Cohen's d. Notice Cohen's d is not actually between, within this. It's outside of that. Cohen's d is just a test that provides you information you need to convert it into an effect size. In this case, our effect size is negative 0.784. Remembering the negative is not something we really care about that much, and this is showing a medium to large effect size. And that is how you would report it in writing, as, you would provide the Cohen's d, you would provide the effect size, and you would describe it as medium to large.